The Electro hydraulic steering gear is a system which provides power operation of the rudder through remote control. On this diagram of the system, we will see how a rudder turn is accomplished. When the wheel is turned in the pilot house, the transmitter sends a signal to a receiver in the aft steering room. The signal is relayed through a differential control to a hydraulic pump. The pump hydraulically operates dual rams connected to a revolving crosshead, which is keyed to the rudder stock and in turn to the rudder. As the crosshead turns, each ram moves a follow-up rack, which connects back to the differential control to return the pump to neutral when the assigned helm angle is reached. Now let's take a closer look at the operation of the entire steering gear. It consists of three major components: the transmission system, the dual power unit, and the ram group. The transmission system transmits the remote control order from the pilot house to one of the two pumps in the aft steering room. There are three types of transmission systems currently in use by the Navy. First is the hydraulic telemotor system, in which the transmitter is connected through hydraulic lines to one telemotor receiver unit, which is connected mechanically to both differentials to stroke port and starboard pumps. Second is the mechanical system, consisting of a wire cable which can be connected to a mechanical differential which strokes a pump. Only one power plant is used in this system. And third is the electrical system, which is the most widely used. In this system, the transmission and power units are usually duplicated, starboard and port, except for the pilot house wheel and transmitter, which are common to both transmission systems. In this film, we will show the operation of the port units. This is the way the electrical system operates. The steering wheel, operating through a gear train, drives the armature of the synchro transmitter. This action changes the transmitter's output voltage, and the output voltage change is transmitted to the synchro receiver in the aft steering room. This causes the armature of the synchro receiver to turn in synchronization with the transmitter. The receiver operates through a differential to stroke the pump. In the event of casualty to the electrical control system, the trick wheel in the aft steering room may be used for manual control of the steering gear. The synchro receiver also operates a limit stop to limit movement of the steering gear differential so that the maximum operating right and left rudder angles cannot be exceeded, thus avoiding damage to the system. The limiting action is provided through a threaded shaft and traveling nut arrangement. Any rotation of the synchro causes movement of the traveling nut one way or the other, according to its direction of rotation. If maximum rudder angle is assigned, this traveling nut movement continues until it encounters one of the stops. The movement of the receiver is then stopped. The receiver is mechanically geared through the differential control to the stroking mechanism of the pump. As we will see with this demonstration model, the differential control consists of two pinion gears and two planetary gears connected to a barrel or a disc cam. One pinion gear is keyed to the synchro receiver shaft. The other is keyed to a shaft driven by the follow-up rack. Each of the planetary gears is in mesh with one of the pinion gears. They are also in mesh with each other, so that the 4 gears form one train. When the signal is transmitted to the synchro receiver, its pinion gear turns. The other pinion gear will not rotate, because as yet there is no follow-up action from the rams, which have not moved. Therefore, the planetary gears must walk around the pinion gears. This action rotates the cam. One surface of the cam contains a roller in mesh with a yoked lever. The yoked lever contains a second roller which engages the indent in the cam. As the cam rotates, the cam roller carries the yoked lever with it for a small part of its rotation. The yoked lever revolves about an external pivot, but it will move with the cam roller only until the cam swings the roller out of reach of the yoke. At this time, the second roller on the lever is out of the groove and in contact with a constant cam surface. Thus, the lever is held in this fixed position as its roller rides on the rotating cam. The movement of this lever mechanically moves a tilting box in the hydraulic pump. The tilting box controls the direction and quantity of oil pumped to the ram cylinders to accomplish, for example, right rudder. However, if the cam is rotated in the opposite direction, the tilting box will be tilted opposite and left rudder will be obtained. Thus, the transmission system fulfills its function by transmitting the steering wheel order to the pump. The power unit receives the transmission signal and, in response, supplies power to move the rudder. The unit includes a variable delivery hydraulic oil pump run by a non-reversing electric motor. This is the way the pump operates. Pistons in the pump are connected to the circumference of a socket ring. They ride in identical cylinders, bored in a cylinder barrel. The socket ring is affixed to a rotating shaft by a trunnion block and pin arrangement that allows it to tilt with the tilting box in either a forward or backward direction on the shaft. At the same time, it rotates with the cylinder barrel. When the socket ring is tilted during rotation, each piston is forced to reciprocate in its cylinder one stroke for every half revolution of the shaft. The side of the pump through which each piston is pushed in a forward direction is designated the pressure side. The accumulation of all piston discharges passes through an orifice in a valve plate. This orifice handles all discharges simultaneously as a steady discharge flow. As the shaft, socket ring, and cylinder barrel rotate through the other half revolution, the piston moves through a complete withdrawing stroke. This creates a suction, which draws fluid in through an orifice in the opposite side of the valve plate. Fluid enters the orifice through a single hydraulic line on the suction side of the valve plate and discharges through another hydraulic line on the pressure side. When tilted in the opposite direction, pressure and suction lines are reversed. These main hydraulic lines are connected to a 6-way valve. This 6-way valve is used to transfer fluid power from either power unit to the ram group. Thus, it can be seen how the power unit receives the signal from the transmission system and delivers power to the ram group. The ram group is the mechanism which turns the rudder and activates a follow-up gear to stop the rudder at the assigned helm angle. The ram group consists of 2 rams, each free to move in opposing cylinders, and a crosshead. The crosshead is keyed to the rudder stock and is provided with yoke arms, port and starboard, within which sliding blocks travel. The rams are fastened to the sliding blocks so that their movement is transmitted to the crosshead and in turn to the rudder. High-pressure oil comes from the pump into the forward cylinder of one ram and the aft cylinder of the opposite ram. The oil pressure thus exerts force on one ram aft and the opposite ram forward, moving the crosshead, which turns the rudder. As the rams move in accomplishing a starboard turn, fluid in the aft port and the forward starboard cylinders is discharged through the hydraulic lines to the 6-way valve and thence back to the intake section of the pump. The movement of the rams also operates a follow-up rack on the ram. This rack is connected to one of the pinion gears in the differential control. When the wheel in the pilot house stops turning, its synchronous pinion gear in the differential control also stops turning. Meanwhile, movement of the follow-up rack turns its pinion gear, causing the planetary gears to walk around the stationary gear, back to the neutral position. This reverse motion of the planetary gears reverses the rotation of the cam. This reverse rotation of the cam will continue until the roller on the yoked lever falls into the indent on the cam and resumes its neutral position. The resulting movement of the lever moves the tilting box in the pump back to neutral, and no oil is pumped. Now, the chain of events which started when the steering wheel was turned is completed, the rudder having been turned to the desired angle and all elements of the steering gear neutralized, awaiting the next order from the helm. We have seen how the electro-hydraulic steering gear operates through its 3 major components. The transmission system sends the signal to the pump. The dual power unit supplies the hydraulic power to move the rams. The ram group actually moves the rudder and activates the follow-up rack to restore the pump to neutral. The rudder turn, begun with the movement of a wheel in the pilot house, has been accomplished quickly and efficiently by the electro-hydraulic steering gear.